Hi, I hope you're doing great. Today, we will discuss a new topic called the precise definition of a limit. In the past video, I taught you an introduction about limits, but now let me show you the formal definition, the standard one used today. So I'm going to read it to you right now. It might sound a little bit confusing, but later on, I will teach you more in a more step-by-step process of how to get to that. So, let f be a function defined on an open interval containing c, except possibly at c, and let L be a real number. So you all know that the limit of f of x as x approaches c is L. This has been taught in the last video. That means that for each epsilon greater than 0, there is a delta greater than 0, such that if x minus c is greater than 0, but it's less than the delta, and then the absolute value of f of x minus L is less than epsilon. So as I said before, this might sound a little bit confusing, but now let me show you the step-by-step process. So first of all, let's focus on this phrase. F of x becomes close to L. Notice that when I say close, it means that there is like a range before getting into the L. And let that difference be called epsilon. So basically, you could say that the interval between those values between the L is L minus epsilon to L plus epsilon. You could see it here that the difference, let me paint it a little bit of a different color here. The difference between these guys is the interval, it's L plus epsilon and L minus epsilon is this thing in green. So now you could write that as an absolute value form as one inequality, and that would be the absolute value of fx minus L is less than epsilon. Now that was for the f of x becomes close to L. But what about the x approaches c? So this is the part of the limit that's right here. Let me show you this part of the limit. So x approaches c. Now in this case, you notice that x is getting close to c. It's not actually at c, but it is close to it. It is approaching it. So in this case, the intervals will be c minus delta comma c, 2, and the other interval will be c comma c plus delta. So it's basically this difference in here. Notice how this point is c comma L, and here is the difference. Basically, these are like the x values, okay? So then you could say that if I were to write that in the absolute value in an inequality form, will be that x minus c is greater than 0 but is less than delta. Okay, so now let's do an exercise applying this. So we have to use this definition, the epsilon delta definition of limit, to prove that the limit of 3x minus 2 is equal to 4. I'm sorry, the limit of 3x minus 2 as x approaches 2 is 4. So basically what we must do in this type of problem is to show that if the absolute value x minus c is less than delta, then f of x minus L, absolute value of that, is less than epsilon. So first of all, people tend to work with this part of the inequality, which is the absolute value of f of x minus L is less than epsilon. People tend to work with this first. But first, let's define what will be our f of x and our L. So that will be the same thing that we did before in the limit of here it is, the limit of f of x as x approaches c equals L. So you already know what each value will represent. In this case, 3x minus 2 will be our f of x, 2 will be our c, and 4 will be our L. So if we were to write it into this form, it will be absolute value of 3x minus 2 minus 4. Absolute value is less than the epsilon, and the epsilon will just be the same epsilon, okay? So now we must work with this, and that will be like this. So first step is to solve what is inside of our absolute value. So that will be 3x minus 6. Notice that I just subtract or add these two things in here. And that is less than epsilon. Next, we can factor out our 2, our 3, which is in both monomials in this f of x. So that will be absolute value of 3 parentheses, x minus 2, like that. Next step, we can factor out, we can get out of the absolute value the 3, because we know that the absolute value of 3 is 3. So that will be 3 absolute value of x minus 2 is less than epsilon. And then we can leave the 3 to the other side dividing, so that will be x minus 2 is less than epsilon over 3. Okay, now we're gonna let delta be epsilon over 3. And now we must work with the other part. And the other part will be x minus c is less than delta. And remember that our c is 2. So that will be x minus 2 is less than delta. But delta is also epsilon over 3. So x minus 2 is less than epsilon over 3. Now, the actual part of proving that something is right is to work with this inequality and try it to get the same as this one. So basically we're gonna start with this and try it to look as this one that is on top in here. So let's try to do that. So we have that x minus 2 is less than epsilon over 3. So let's start with that. First, we can move that 3 to the other side multiplying. That will be 3x minus 2. And then we can multiply the 3 by everything that's inside the absolute value. So that will be absolute value of 3x minus 6 less than epsilon. Now, our minus 6 could also be written as minus 4 minus 2 is the same value. So then the answer will be 3x minus 2 minus 4 is less than epsilon. And notice that this is the exact same thing as this in here. So then we can say that we have already proven the limit. I know it's a little bit confusing, but it can come in handy sometimes. So that was a precise definition of a limit.